welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 2 of the series of lessons on the normal distribution, and in this video we're going to be looking at the inverse normal function. So I've got two questions up on screen here. Looking at the top one, if x follows the normal 58 6 squared, and if the probability that x is greater than a is 0.3156, find the value of a. So whereas in the previous example we were given the value to find the probability above or below, this time we're being given the probability and asked what's the value. So a pre-drawn out normal distribution here. X follows the normal 58 6 squared. I'm just going to do the normal thing where pop a little line in at the mean of 58. And I'm being told that the probability that x is greater than a is 0.3156. Now, you've just got to have a little think about that. X is greater than a certain value, so the area that we're looking at is going to be to the right, and it's less than a half. So that tells me that the a has to be greater than the mean, so it has to be on this side of the distribution, and the area to the right of that is going to be 0.3156. So just getting a sense of where that value is in relation to the mean is really helpful with these questions to check that the answer that you get is correct. Now, on your ClassWiz calculators, there's what's called an inverse normal function. If you go menu 7, it's option number 3. It's going to ask you for three things: the area, the standard deviation, and the mean. And if you can give it those three things, it will tell you the value that you're at on the horizontal axis. Now, the thing about the area is it wants the area to the left of the value that you're trying to find. So here, we're not going to tell it the area of 0.3156. We're going to put in 1 minus 0.3156, because that's going to tell us the rest of the area to the left of that line there. Now, standard deviation is 6, and the mean is 58. So if I put that information into my calculator, it will tell me that A is 60.88. That's to 2 decimal places. Now that makes sense because we thought that A was going to be above the mean, and the probability of being greater than that is about a third, which makes sense as well in the context of this question. So on to the second example here. The reason I've got this one, a couple of reasons. One is it's the probability of h being less than a value, so it's going to be the other way. But the other thing you've just got to watch out for is that here, rather than being given standard deviation squared, we're given 144, which is actually the variance. So very important to note, and I'll jot that over here, that the standard deviation of this distribution here is 12, not 144. That's the variance, which is the standard deviation squared. Okay, so again, I'll put in my line for the mean in the middle, which in this case is at 165. And I'm being told that the probability that h is less than a value is 0.8106. So the area to the left of my line is more than a half, which means that my value of h must be up here on the above the mean. And this area here to the left is going to be 0.8106. So again, if I go to the calculator, the area, it wants the area to the left. I have the area to the left, which is 0.8106. So I can put that in. The standard deviation we know is 12. The mean we know is 165. So I can give it that information, and it will tell me that h is 175.6. That's to 1 decimal place, which again makes sense. We expected a value that was greater than the mean. Drawing the picture has helped us get a sense of what our answer is likely to be and check that the answer that we get is realistic. So always a good idea to draw a diagram. Okay, join me in the next video where we'll look at finding nu and finding sigma.